Good morning, everybody, and welcome to our final webinar of UK Radon Awareness Week 2020. We're delighted so many of you are joining us today, and our last session is being hosted by Paul Colbeck of GeoShield, and we'll be discussing radon protection for new construction, how to get it right first time. Before I hand over to Paul, just got a couple of admin bits to do with the software we're using today. As you can see on the right hand side of the screen, there's a chat box. Please do say hello to us, have any discussion you want in that box. It's always good to know, have your comments there. If you've got any specific questions though that you'd like Paul to answer at the end of the session, if you could put those in the questions box, which is underneath the presentation screen. So if you scroll down underneath the presentation screen, there's a box specifically for questions. If you post your question there, that's where I'll be looking at the end of the webinar to ask those questions directly to Paul, just so we don't miss anything that you urgently want answered that might have got lost in the chat. So we're going to be about half an hour this morning with some questions at the end. Hand over to Paul now, who's going to run you through the presentation. Thank you.
Hi there. Can everybody hear me now? Is that all live now?
Yes, you should be, Paul.
Good. Yeah, I'm going to do a quick presentation today on radon protection in new build housing. It's going to be a pretty lively one. There isn't much text or anything like that. It's fundamentally nice pictures and everything like that. So I should be able to whiz through this quite quickly. I've been in construction for 30 years. I've been involved right from the start when it was brilliant. You could run around in your underpants and all you were bothered about was fundamentally getting a tan. Then I moved into waterproofing and basements, and I got the chance to go all over the world with this. So in 2015, I joined GeoShield, got involved in ground gas validation verification, and quite enjoyed the experience. So I then got a chance to become an MVQ2 assessor for the installers and got involved with the MVQ4 for the verification of ground gas systems. And also then I became the chairman of the BVC, the British Verification Council. So I'm quite heavily involved in verification and ground gas. This presentation is an introduction into current practice in regards radon protection for new housing construction from large developments to single house and small building projects. The presentation will cover really from construction, from the construction strategy from inception to the completion. So you've probably, if you've watched any of the previous presentations, you'll have been told what a radon is, so that will be very brief. Then I'm going to talk about why protect housing against radon, the current attitude in the housing sector, legislation and conceptual design, non, basic and full, typical housing construction, radon design, and then finally verification. So what is radon? So radon is an odorless, colorless radioactive gas. It is formed from the radioactive decay of small amounts of uranium, and that's it, really. I'm not going to cover it anymore because you've probably been talked to death on this. You can see it can come into your building through basements, ground floors, toilets, fundamentally everywhere. So, and obviously then it results in my boss just on the top right there. So radon. Why is it essential that we protect new building housing against radon? Approximately 1,100 deaths per year. Should we take this seriously? Well, I've been in ground gas 5.5 years now. It seems that 1,100 figure hasn't changed for 5 years. So we can't really be doing anything better. So to my mind, we've got to start doing something differently. Again, radon deaths. Well, smoking, the government spends a fortune on telling us not to smoke. Road accidents, again, it goes through all this procedures and all this advertising to tell us not to die from road accidents, or instructing us how not to do it. Drink driving, again, accidents at work, we have a full legislation there, the 1974 Health and Safety at Work Act. Yet lung cancer from radon at home is third on that list, and there isn't a lot out there. There isn't a lot of awareness. There isn't a lot of education. So something a little bit awry there. Comparison to waterproofing. I get a lot of ground gas questions asked about, oh, well, we don't do this for waterproofing. Well, the reason is for waterproofing is you don't fundamentally die from waterproofing. It's an inconvenience. It sometimes looks bad. You might get a bit of mold. And also you can easily put this right. It's not hard to repair, particularly waterproofing leaks. There are quite a few solutions out there. But the consequences of radon are, well, pretty grim, as we can see from the figures. So education, the current attitude in the housing sector. We need more education out there. The industry tends to ignore radon. The contractor, the installer, and the buyer. Now, the contractor with this tends to, I find that he doesn't want to highlight the fact that there may be radon on his site because it may affect his future sales. And, that's a key thing for him. He's got to sell his houses. And if he feels that the radon issue may be an issue, then yeah, it's not going to look good. Current practice, radon gas remediation systems are installed predominantly by house builders and their subcontractors who have no knowledge of the ramifications of poor install. This lack of knowledge extends from senior management right down to the installer. Now, you can't blame an installer if he's treating the radon barrier as a DPM. You can't. And the senior management, they need education as well to understand the ramifications of poor install. So, this is something, hopefully, presentations like we've had all this week have highlighted. There is a misconception out there that, yeah, okay, I've got a new house, I'm brilliant against radon. Well, a new house, they do air tests, that is a sealed box on top of the ground. If you don't have good radon protection, the radon is trapped in there. Old houses, they've got rubbishy wooden windows, they leak all over the place, they've got good airflow inside. So they've got potentially good radon protection. So there is a complete misconception there between old and new build. Again, awareness. Now, I saw this about a month ago and I thought this was brilliant. I was watching an episode of The Simpsons and Bart had befriended this hobo and he said, go and live in the basement. And he said, oh, do you know what radon is? And the guy said, no. He says, oh, okay, then see you later. So, radon is there and it is an awareness. So, and to see it on The Simpsons, I thought, The Simpsons actually even predicted the current presidents of the United States. So interesting piece. This I saw in Switzerland, and I thought this was brilliant. This particular slide was, as I understood it was told to me in Switzerland, was that there was an old lady who had a basement, and she didn't believe there was radon in her basement, and all the readings showed excessively high levels. So they thought, right, okay, we're going to build this cloud chamber in her basement and show her the fact that there's radon in her basement. And literally, as soon as she saw this, she wanted stainless steel lining in her basement. She wanted everything. But I thought that's a great visual representation of the radon isotopes. Great. So I'm going to move on to legislation. The overriding document for radon is document C, building regs. We've got basic radon is required for estimated with 3% or more properties that will be affected by higher levels of radon. And where it is 10%, we require full levels of radon protection. So fairly straightforward in my mind. In addition, local planning authorities may increase the requirements. I noticed there are some up where I live, up in the north. He may ask for a radon barrier or full radon protection, which is verified, regardless of what radon is in the ground. But that's down to local planning authorities and planning conditions. But they make it particularly clear in their particular area. So that's one thing. So then we come on to conceptual design, which again I think is great. So it's so easy. We've got BR211, the maps, which clearly show non-basic or full protection. I'll go into these different types of protection a little bit later. But we've got the maps here. You can go into whatever this is. I think I've used map 16 off map 16. Oh no, sorry, I haven't. And there we can see there closing up. There we go, and you can see the full, basic, or none that's required in that particular area, and it's pretty accurate. We can also use Public Health England and explore their interactive map, which again is great. The amount of people that come to me, customers saying, well, we want to know what radon protection we require. And I said, well, just go on to Public Health England, put your postcode in, and it will clearly tell you what you need. So postcode in there, it tells you what the levels are. And to take it a step further, you can ask for a radon report to be issued, and it will tell you fundamentally there in that postcode whether you need non, full, or basic. So this conceptual design is very, very straightforward. So I'm going to talk about a few typical ground floor methods that we use in England and Scotland. England primarily, I would say, built from beam and block or the segmental floor. It's quick, it's accurate. They've been building like this for a long, long time. Concrete beams, infill with concrete blocks. They used to put a concrete slurry in to make sure the blocks used to stay in place, but they don't seem to do that anymore. But yeah, predominant method I would say in England is the block and beam. They've slightly adapted it even further now with new technology where they're putting big insulation pieces in there in between. The initial ones, they used to be a nightmare when you used to be verifying it because they were quite thin and you used to just fall through the damn things. But then we've got all these beams that all come in one, which are all fully insulated underneath. So again, it's increasing that program time, which is much quicker. U values are much better. So yeah. So this is the build processes we have in the UK for house building. We have a few interesting ones with polystyrene void formers. They're accurate and robust. Can be used if there's clay heave. Not so much used in housing as such, although they are. It looks like they are here, but it is an option if the build process wants it. Then we have our rafts. To me, a raft is a concrete structure which extends to the outer leaf. Which is the top left one. It's just one piece of monolithic concrete that is casting one. The other picture shows what you sometimes see in Scotland, where they will class this as an actual raft construction. It sometimes sits on the inner leaf as well, but to me, this has a direct route for ground gas to seep in between, shown on the red arrows, on that interface between the internal leaf and also going up the cavity. Whereas if you have, like the top left construction, there isn't an issue there. The ground gas can't do that. So it's just different methods in different regions, really. But primarily in Scotland, they will class a ground bearing slab, that one that sits on that inner leaf. So it's just different construction methods and different risks to be aware of when you're constructing, you're designing your ground gas system. So, new housing radon design. So no radon protection, 0 to 3%. Well, properties will be affected by high levels of radon. Due to the nature of the radon maps, they're not 100% in these white areas. It may be that they've not taken enough readings. There may be spikes or that type of thing. So it is recommended that the completed property is tested on completion. It makes sense. And if there is provision in that new build to if you've got a suspended if you've got a block and beam, it's easy to put a sump under there and lower the radon levels. So with these types of construction, it's essential that you do test after the building, after the property has been constructed, and tested when it's been built fully, with the central heating on, the windows in. There's no point testing it before then. So then we'll move on to basic radon protection, 3% to 10%. So following guidance, basic protection consists of membrane protection. Specification from BR211, at least 1200 gauge polymer. Care should be taken in the build sequence, workmanship and competence of the installation should be considered. So that's taken direct from BR211. It doesn't really go as far as saying it must be validated or must be verified, like you would do for carbon dioxide and methane. The BBA has a new policy for the minimum thickness of membranes intended for use as radon barriers, and should be a minimum of 0.4. This will directly affect housing projects that have warranty providers, as they may require this specification to hold a BBA or equivalent. The NHBC, I think most of their products have to require this type of testing certificate. So, it's already saying, well, 1200 gauge, it's not really, it's not really suitable. It's not really robust enough to stand that build process. So, the BBA has identified this, and I think manufacturers have identified this, and it's to my mind, it is a good move. There we see with the membranes installed. It's these are obviously good application. You can see how complex the shapes are there, 3 dimensions, 2 dimensions, and how easily it can be done. You can see pipe penetrations coming in there. On the bottom left, you can see this group of services and utilities coming in one. They can all be detailed by specialist applicators. Yeah, it can be done, but it can be done very badly as well. Just a couple of photographs here, or some photographs showing, how corners are detailed. The bottom one on the bottom left, is an excessive detail, but a specialist can easily do something like this. The top left is a different type of construction, where often as not, sometimes the build process will want they will put something like a gas resistant DPC in first, build the building, and then they will do the infill, just for that preferred build process. So that's got to be really considered. That's got to be considered as well. The build process in relation to ground gas membranes has got to be considered. Membranes can either be taped or welded. Your specialists will often predominantly weld. Your ground worker or the subcontractor on there will often as not tape. Again, there you go. A taped membrane. Again, people think when they come to put a tape membrane, it's simple. You just lay the tape out. Well, it's not. You've got to roll it. You've got to make sure all the air bubbles are compressed out of the tape. At the top of the photograph, you can see where it's all bubbled up, and the tape hasn't been pushed into the membrane, so it's a direct route for gas. Just a typical CAD drawing there showing how the membrane will go across the cavity. That's a typical beam and block design. The cavity tray at the top will come into the same joint as the gas membrane. And if that does, then building regs state that you have to use a dual tape in there to glue them together so it doesn't create a slip plane between the two. But again, it's straightforward application. Again, it is recommended that 3 months testing is completed. This aids the homeowner and also provides design information that the radon design that you have used on your development has been successful. Again, the question always arises that will this knowledge affect future sales? So does the builder make this knowledge available? Also, cost implications. It will identify if the application is poor. So if the application is poor, then they're going to have to do some remediation items. They may have to stick fans in and etc. You know, that's if they've built 100 houses and they're all affected, that's 100 fans. That's a lot of money. So new build housing are a little bit reluctant to use these simple 3-month monitors to test their robustness of their design. Full radon protection, so it's greater than 10%. Full radon protection requires a membrane and venting. Following BR 211, to support the application of the radon barrier, the quantity of radon reaching the barrier to reduce the sumps by provision of radon sumps or ventilated subfloor voids. There are a few others in there, you know, the polystyrene void formers, etc. But I'm just going to concentrate on these two. Radon sumps, you've just got to be aware of the compartmentalization beneath the building, but straightforward. They're the radon sumps, great. If the radon levels rise, then you can add a fan. A vent mat can be sometimes used under a raft. These are, you know, you can have a design calculation for these and working out the number of vents so it performs correctly. It works very well. You can see this concept here, the position of the 25mm vent mat, and then that is taken out to a telescopic air vent. If there is an issue again with the performance of this system, then you can position a fan on the telescopic air brick. Beam and block, we'll discuss this really. Telescopic air vent, the ventilated void. It's a very good system. Is a beam and block, very efficient system. Often as not, you will have a vent void of 250mm under there, and they don't often put the air bricks in at less than 2.5 meters anyway. So you've got a very efficient air change underneath a block and beam. So the last item I'm going to cover is verification. I suppose that's my skill set really. The importance of radon protection, and this has been explained in the previous slides. However, due to human nature, we get poor workmanship. Do we care? We fundamentally a lack of knowledge. A program, you know, you've got your site manager wanting 150 houses built in 2 days. Friday afternoon, well, Friday afternoons, you want to get away from work, you throw it in saying, yeah, I've completed that and it's done. Poor design, you know, it still happens. Wrong materials, you know, they could be using just a straightforward damp-proof course which uses recycled material. Sorry, damp-proof membrane which uses recycled material. and they'll take shortcuts. I've seen once where they've had the NHBC inspector inspect a force slab, and as he's gone, they've literally picked up the whole ground gas membrane, concrete it, picked it up, put it in another plot, and then cast the concrete and carried on. You know, they'll do anything. Some building company, I don't say they'll do it now, but I've seen that on a couple of times on projects going way back when I was a site engineer. So verification, there is guidance out there, and I think pretty clear guidance. In BS 8485, yes, it is carbon dioxide and methane, but there is an annex in there which says you treat it the same as carbon dioxide and methane. So you should be verifying it in accordance with Series 735. Good practice for testing. This also includes radon. BR 211, guidance on protection. This doesn't quite go far enough, but it does say that, you know, records should be taken. So it's something to bear in mind. There is guidance drifting towards verification, telling us we should be verifying, but we're not. For carbon dioxide and methane design, it is recommended at least 2 forms of protection should be utilized. As described previously, radon membranes are not verified predominantly, and the installation is poor. To depend on ventilation as a primary defense is a risk. Now, this is predominantly what happens in privately owned houses. They will put in decking, they will put in planting, they will put conservatories, and they will put planting down the house. Now, this one here is my house, so, you know, I know a little bit about ground gas. So, you know, if I'm doing it, then, you know, you've got to sort of think, well, other people are doing it as well, and that's restricting the performance of the gas protection systems. Again, you know, this comes down to design levels. It'll look great on a design on a piece of paper, but when it actually comes down to site and the levels are there, these telescopic air bricks get compromised. I did a little survey of my estate, and I walked around it because I can see over the hedges and stuff like that. And 27% of the homes on my 11-year-old estate, of 112 houses, had been compromised, had compromised the venting. I got my guys to go around other estates, their estates, and it varied between 14% and 37% of these estates that had venting that was compromised. So if the membrane is not installed correctly, it's not good. So this is something, hopefully it'll work, is to show the result of a badly installed membrane, and the result of a badly installed membrane. So what you can see here is that this is how it would be treated if they were installing it like a DPM. So you can see the smoke test showing all the problems that's associated with that. So that's typically how a ground worker would install a radon barrier, but treat it as a DPM. Okay, and then when you get a follow on, you get a specialist coming in and you would treat it up and tape it correctly, then that's the result, and you have no leaks. Membranes for radon. Typical radon membrane installation, nearly all radon barriers are folded. Now, this is a bit of a problem that I've come across while I'm being verified. The fold is a memory in the membrane. Now, screeds that go on top of these membranes are very, very thin. They're only 50 mil. Now, if you're using something like a fiber screed, then what you're doing is you're creating a crack inducer, because that rises up between 15 mil, or it can do, because there's no weight in the concrete for 50 millimeters. Also, if the concrete is pouring against the lap, then concrete will go into that lap and open it up. So radon barriers that are folded need special attention. This is not so much a problem if you've got steel going on there. However, you must treat a folded lap potentially put a patch on there to hold that lap down, hold that crease down. 1200 gauge. This is not really robust enough to withstand the build process. Somebody walking on it, somebody putting steel on there, it won't withstand. And also what I see as well is a lot of them aren't made from virgin polymers. The new specification, BBA, the membrane is much more robust and can withstand the build process much better. It's a product that's fit for purpose, really. Typical installation that you come across, this guy was absolutely over the moon. He couldn't wait to show me this. He thought he'd done a fantastic job. And as you can see, well, there's a direct route for gas. It's poor, but he thought he'd done a fantastic job. So current levels of verification in radon, level 1, and you gotta consider that there is no one that they have to go to in carbon dioxide and methane. If the risk is CS2, then they've got to go to level 4. But in radon at the moment, it's up to the contractor really to choose which one he wants. So he could go to level 1 where there's no verification, or level 2 where there's no verification, but he will take his own photographs, which will often be a mess, a mishmash. Or level 3, which is no verification, but he's audited contractor evidence, so that they will collate that and then maybe issue that to a verifier in an audited fashion. And then there's level 4, which is independent verification in accordance with Series 735. So pre-verification plan to validate correct design, correct materials, verification reports, and handover certification, hopefully with a 3-month test at the end. Pick and probe test for verification. Straightforward, great for checking the integrity of membranes. Dielectric testing, this is great. It's a spark test, especially for radon barriers which don't have the aluminium foil. So it just puts a spark through and it will identify, it'll send a reading on your monitor there to say that there is a hole. Really good for radon barriers. Air lancing, 50 psi, 50 mil away, and it will whistle at you if there is a defect in the lab. Inert gas testing, this can be done retrospectively or on new build using change, pump in an inert gas. We use helium, go around with a monitor, and it will identify where any leaks are. Specialist install, something you will definitively see the difference. There's definitive advantages, they're much quicker, etc. The quality, you can reduce the verification costs if you're using a specialist as well. So yeah, one thing to notice on the left, you've got plastic trick track. A ground worker will put it in the other way, which is the correct way, but the knobbles will go straight through the membrane. But a specialist will know to put it the correct way around. Current attitude among UK house builders and warranty providers is that the installation of radon remediation systems should not be independently verified. Now, that was in a webinar by a warranty provider. And this is in complete contrast to methane and carbon dioxide. Now, methane and carbon dioxide, as far as I'm aware, have had no deaths in the last quite a few years, where radon has. So we've got to stop working against each other here. The industry has started to take note. A project manager in Scotland, you know, he did some validation certificates himself. He made them up, and he was put in jail for 6 months. So, you know, the industry is starting to turn a little bit. In summary, so understanding the design requirements, increase site knowledge, better materials, better installation, verification and testing will achieve proactive radon protection. That's what we want, proactive radon protection, rather than reactive radon protection, which is after the event. So I've probably bored you to death, so it's back to you, Rebecca.
For that run through. Hope everyone can hear me again as I muted my mic. Thank you for that. That was really interesting. You raised some really valid points there, things that we should all be considering and questioning why radon's being treated so differently to other ground gases. We have got a few questions here that have come from our viewers this morning. So I'll just go through those. The first one here is from Shahid. I think it was interested in the video you had up of the radon decay from Switzerland, and he said, was that information published anywhere? Do you know where that came from? Can we have a link to any more information on that?
Yes, if you go on YouTube and search, I think it's the biggest radon cloud chamber. It's just there.
Okay, so
search radon cloud chamber, and it's just there.
Okay, we'll go and have a look for that then. Thank you. Next question from Martin, who says, would you agree that what you call verification is actually a quality control process, and that the 3-month test is actually the verification?
No, not at all. I think quality assurance is part of verification. You know, the verification is making sure that the installation of that ground gas membrane is installed correctly, and you want it to be in that stage. What you don't want is fundamentally that 3-month monitor find out the work. You want to stop that getting all the precautions that you put in place, all the expenditure that you put in place on radon barriers and put in incorrectly, so you don't get a bad result. So that's verification of the installation. Yes, it is quality assurance, but you could say that the 3-month monitoring is quality assurance as well. I think it's just arbitrary terms, really. Verification is quality assurance. Yeah, but so is putting the 3-month monitoring also comes in our verification package. So is it quality assurance as well? I would say yes, it is. It's making sure the quality of the installation is correct.
Okay, so yeah, both have a part to play.
Yeah.
Okay. Next question here is from Matthew Spiller. As a genuine membrane manufacturer, I would be interested to hear how much more robust you believe a 0.4mm membrane is over a 0.3.
It's just on experience. I think. I think I'm more. I know where Matthew is coming from here. I would say that the thicker membrane from the that's been specified from the BBA is better than is more robust. I don't think I can say any more than that. If we are putting in a more robust membrane, and it can withstand footprint, you know, it can stand steel getting on there, it can stand footprints getting on there, and the whole build process better than a 0.3 or a 1200 gauge. I do, and I think that's why the BBA has brought this new certification in and this new requirement in.
Okay. Next question from Jaroslav, all about lifespan of membranes, and he says that most, if not all, polymer membranes will degrade over time, losing its radon barrier properties. That will most likely happen before the lifetime of the building. So what's the approach to address this?
I would say that's a manufacturer's question. I mean, as a verifier, we would look at the technical data sheet, and they're providing material which has a material warranty, which you would hope would withstand the lifetime of the building. You know, they're providing a material that's fit for purpose. I think that's a question I would ask of a a manufacturer. I don't have the knowledge of that one. I must admit, the information and the testing that I've seen, it does survive the lifetime of the building, but I don't have the knowledge of that one. I'm sorry on
Okay.
that one.
I believe there is, Martin's commented, there is some good published work research into this being done in the Czech Republic. So if anyone wants any more information, possibly search for those papers. Perhaps it's an argument for why we should have a combined approach with a ventilated system as well as a barrier, and not solely rely on barriers, perhaps.
I would agree. I would agree. You know, when you look at the build process in the UK, it is predominantly a combined system with block and beam. So you do have a combined system with the venting and the membrane, but it's typically with a Type A building, it's what the homeowner then does to his house afterwards, which is why you have to have a membrane and not just rely on venting. But you know, I've seen some of the research from the Czech Republic, and you know, it hasn't indicated to me that it would degrade, the membranes would degrade sufficiently enough over that period of time. So yeah, but a dual system, like Martin has said, that that's ultimately the way to go. But it's all about, you know, in Scotland they predominantly build with rafts, and so it's more difficult to put in a venting system in there. It's an additional part of the construction process. Okay.
I've got one more here from Shahid saying, are you recommending every new build is monitored and mitigated? Who will pay for it?
I'm not recommending all buildings should be radon protected. I think you look at, it's fairly clear on Public Health England and BR211 which one should be protected, and that's
I think the question is, should they be monitored? Should they all be monitored? So on completion, should every new build have a radon test?
I would recommend so, yes. If I was buying a new house, and from the knowledge that I have, I would want my house to be radon tested, even if I was in an area that had no requirement for radon protection, purely because if I come to sell that house, most conveyancing companies now are asking for a radon test regardless of where you live in the country. So it's I mean, my sister's moved into a new house, and that's in a no risk area, and I recommended she got a radon monitor done. So yeah, I think it's a very low cost thing to do. So I think it's a good thing to do, good practice.
Definitely. I personally bought a new property in a high risk area at the end of last year. I tested it. I checked with the builders what protection was installed, but I'm going to be going around like you did around your development and counting up how many of the other houses have blocked up the air bricks and things, and see how much is still actually active and working. I've got one quick question for you, Paul. From your experience on site doing your verification, is there one most common failure that you see? What's the most sort of the crucial point that lots of people get wrong? Is it jointing? Is it service inlets? Is it particular part of the membrane?
Yeah, it is. The fundamental thing for when you get a radon barrier, and we, as a verification company, we do a lot of verification. We will do nearly 200 verifications a month, and I would say we won't even do 10 that's radon. Now, it's predominantly done by ground workers, and what they do is treat it like a DPM. So when they're putting in a DPM, they'll lay it across the footprint of the building. They'll pull it reasonably tight. They won't tape the laps. They'll put a big star where there's a pipe penetration, and they won't seal around that. And then they'll lay that across the cavity. Then the bricklayers will come along, and then the bricklayers will cut the membrane because it's in their way, and then the bricklayers will put their DPC in. So there is no continuity of the membrane. There are no tapes done because they treat it as a DPM. Simple as that. So yeah, so that's the answer to that, I'm afraid, Nicola.
Great. Thanks for answering that, Paul. I'm having a bit of issue with my sound, so I'm afraid I didn't hear all of your answer, but hopefully everyone else did. That then, we've not got any more questions. So that brings us to the end of today's webinar, to the end of Radon Awareness Week. I want to thank Paul for his presentation today, and for everyone else that's been involved in the week this week. You will, or anyone who's registered for this, will get a link to watch the replay later on today, and it will in due course be uploaded to the Radon Week website. The replay link you'll get today is valid for 5 days. So if you want to go back and re-listen to anything that Paul said, you should get that later on today. And all the other presentations from the week will be uploaded to Radon Week probably next week sometime. So thank you all for listening. Thank you for participating in Radon Awareness Week. Our goal is to spread awareness. So please do share these presentations with colleagues, friends, family members, anyone who you think would benefit from that. And I hope you all have a great weekend.
That's great. Thank you very much. See you later.